a container-based world, because that's, they basically build themselves so that they are easy to deploy in a Kubernetes or another container manager. But that's basically the pattern. Service meshes, they ensure reliable service-to-service interactions and offer a few different features on top of that.
Cool. The next in techniques, I'm going to be talking about polycloud. So we all use cloud. And in the beginning, it used to be just AWS, and slowly there is Microsoft, Google, and a lot more players in the industry. What we are seeing is the competition is healthy, but almost everyone is now, in a way, a feature complete with one another, and there is not a much of difference if today you want to switch from one vendor to another, right? While that is happening, while the cloud is actually maturing in that way, which is good, so we have more than one choice, there is something special about each vendor, right? So if you take AWS, for example, they may do one thing particularly well, whereas if you take Google, they would be offering something like a really planetary scale DB well, and Azure could be having a very good voice to text or text to voice service. The point I'm trying to make is that though the cloud vendors are catching up in features, every vendor has a sweet spot. Now we are seeing a trend where why can't I use the best of all rather than just locking with one vendor, right? So this is completely different from the point saying I want a cloud agnostic solution. That basically means I can take my solution from AWS and drop it to Google or Azure. But what here we are saying as polycloud is embracing this nature of picking and choosing the best from each ecosystem and providing a coherent solution, right? So this is a pattern that we are seeing more recently, and we are experimenting with it. Yes, there are quite a few challenges. This may not work in all contexts, especially when you want to move a lot of data across vendors. But this, if your core product would benefit from leveraging this special services offered from each vendor, I think this is a good technique to actually leverage. I'm going to pick the next one as well. That's the blip number 19, which is sidecars for endpoint security. Basically, this is, with this current era of microservices, everybody is building service-oriented architecture, and lot of interactions are happening. So an usual scenario is this: I have built a service. This is behind a firewall and is being used only by another service. I mean, there is no strict need for security because this is not the real front-end service. But that situation will quickly change, because what is totally an internal service with a very few changes and at scale in an organization you cannot control, this quickly becomes problematic, right? So you basically want any service to be protected, right? And to say that is quite a lot of work. I mean, you need to implement a lot of things to protect a service from the attacks that we are seeing. So it's not easy to say that every service will be protected in a way that we wish it to be protected. So the current thought process is, let each service not worry about this use case and offload it to a completely different and out of process model. So think of, if you're building a service, you're going to deploy a completely another process, and you're going to outsource all the security features to this process, and you only focus on your business functionality, right? So in a way, it is more of a sidecar, and this sidecar will be responsible for termination of your SSL, will be responsible for authenticating, authorization, and all of that, right? And it also goes well with the service mesh that Sudarshan just described. This can also be an intelligent sidecar, and it will be aware of service discovery. What is the service that I need to talk to? So a lot of benefit comes out of the sidecar model.
Mm. Yeah, I think a couple of interesting things around it. I think, Bharani, you briefly touched upon it. Service meshes are implemented using the sidecar pattern. Basically, a sidecar pattern, as Bharani said, is for every instance of your service, of any of your services, there is a sidecar associated process sitting beside the service. In the service mesh pattern, that sidecar will own all service to service communications. It acts as a proxy and a reverse proxy for that service. But in the sidecar as a security approach mechanism, the same sidecar also can handle authentication and authorization between services. So the examples we talked about, Istio and Linkerd, they offer this capability as well. So I guess the broader abstraction is that by using a sidecar with every service instance and by giving it a lot of capabilities so that it can do service discovery, authentication, etc., you essentially get both these things.
Cool. Let's go on to the next quadrant, tools.
Cool. Yeah. So let me get started then. I'll talk about COPS. So I guess, as you guys know, nowadays, it's the era of containers and container management, and Kubernetes is one of the bigger players in the container management space. Now, if you were to ask me, if I have a Kubernetes cluster, which cloud vendor should I go to host it? Normally the default choice would be GKE, because that's a native Kubernetes managed service. But if you were on AWS, there was no easy way to manage a Kubernetes cluster. You have to basically take the ownership of setting up your cluster, managing it, operating it, so on and so forth. And it's not actually a simple job. You'll actually spend quite a lot of effort and money trying to manage setting up and managing your own Kubernetes cluster in AWS. Now, COPS is a tool, open source tool, which was the community's response to how do I make managing a Kubernetes cluster easier in AWS. So that's how COPS got started. But of course, since then, COPS have broader ambitions. They are looking to be the way to manage a Kubernetes cluster anywhere, on-premise, in a cloud, any cloud, in any sort of context, so on and so forth, whether it's managed, whether it's self-hosted, so on and so forth. So they have broad ambitions, but I think it remains to be seen whether people will use that if the cloud vendors come up with native Kubernetes management solutions. Recently, for example, a month or two ago, AWS came out with its own managed Kubernetes solution, and I think it's still a little bit of a debate whether people will now move out of COPS into using that. And if they do, then, is there really a great, what is the future of COPS and stuff? But anyway, this is where we are with regards to COPS. I'll go ahead and talk about Sonaboy next. Sonaboy is also a tool in the whole space of container managers. It is a tool which allows us to run end-to-end conformance tests on a Kubernetes cluster in a non-destructive way. Basically, it allows us to say, here are the policies which determine what the best practices of running a Kubernetes cluster is. And I'll just run these tests against a running cluster, and I'll make sure that it's conforming to those best practices. So it's essentially, you can treat it almost as a way of monitoring your cluster to ensure it continues to conform to your best practices.
Cool. I'll touch upon two things here, the serverless frameworks and Apex. So both the blips are in a way related to serverless computing. There was also a question sometime back about talking about the serverless architecture. So basically, we used to have physical machines, then we had hypervisors, and then we had an EC2, which is making that as a service. And And now at the highest level, today we have serverless computing, basically meaning you do not have to own any physical infrastructure. You have to give the content, and the content here is function, and the platform would scale that for you, right? So that's basically your serverless framework. As in not this blip, that is your serverless computing. So what serverless framework does, it is in a way a framework in JavaScript for you to manage AWS Lambdas. It started with support only for Lambdas. I think right now they also have a support for Apache OpenWhisk. So instead of just writing small functions and using the given online consoles to actually deploy and manage it, these frameworks, both serverless framework and the Apex, let you organize your code. It gives you the same familiarity of a framework, but it gives you a command line tool for you to easily deploy each functions in your cloud vendor and manage your serverless ecosystem that way, right? So both the frameworks have support for more than one language. The point I want to highlight is Apex framework is slightly different from the serverless framework in the sense that it lets you, for example, today in AWS, you cannot write a Lambda function with Golang. Let's say your team has a lot of experience with Go, and you want to write Go functions in AWS as Lambdas. You can use today Apex as a framework. Even though it's not natively supported by AWS, what Apex actually does is it installs a very thin, what they call as a Node.js shim. And this will talk to using console in and out with the language of your choice and act as a bridge. So you can have any runtime, any language, and you can use Apex and leverage the tooling that it provides to actually write functions, even in languages that are not natively supported right now. The difference is Apex today only targets AWS, whereas the serverless framework gives you a choice of either AWS Lambdas or the OpenWhisk, right?
Cool. Let's move on then to the next one, platforms. Cool. So let's start with Google Cloud Platform. I think we have talked a bit about cloud already, and I think one point has come across that all our key cloud vendors, Google, Azure, Google and Azure primarily, apart from AWS, are maturing, and they have almost caught up to AWS in terms of broad capability. AWS had a huge head start, right? They had almost like a 5-year head start, have the widest range of products. I think that continues to be true even now. But I think GCP and also Azure have pretty much the most important parts of the product suite covered, and they're starting to be serious contenders. And in fact, in some cases, in some areas, they are actually superior to even AWS, and to the extent that that's what is creating this move of not only are people starting to move more dramatically to other cloud vendors like Google Cloud Platform, but also that's where you are starting to see the polycloud movement and that sort of thing. So particularly in the space of data engineering and intelligence, I think Google Cloud Platform is probably the market leader at this point, in the sense that they have quite a few tools, that they have quite a few solutions which are very compelling. Now, this is where you will probably end up with the polycloud solutions, because you might already be on AWS, but you might be embarking on a data project, and you might find it very compelling to use GCP. And the other place I think where GCP is really great is also with their services like GKE, which basically is a managed Kubernetes service. And I would still say at this point, if you're starting off with a project and you're not committed to a cloud, GK is probably an excellent choice. So in that sense, Google Cloud Platform is really starting to be very compelling alternative. We are starting to see quite a few of our clients choose Google Cloud Platform over AWS right now.
Right, I'll talk about the Cloud Spanner. So this is from Google. The Spanner paper actually came out somewhere in 2012, if I remember it right. So, for a while now, Google had this capability of designing from scratch and implementing and running a planetary-wide database, right? So this is one of the secret sauce of what makes Google tick, apart from other things. And it was very, very tightly coupled with Google's infrastructure, and it took them a while for them to take Spanner and give it as an offering to the world. And this happened sometime last year, and offering in the name of Cloud Spanner, as in it was the same Spanner technology that powered the internal systems of Google, is now as a service offering to the world. So what is Cloud Spanner? Think of it as the same asset transaction capabilities of your typical RDBMS, but excuse me, but think of it in the planetary scale. So you can provision Cloud Spanner and say, I want it to be replicated across 10 countries and I want 1,000 nodes, and then you will have it, right? So it's a combination of your typical RDBMS with the capabilities of NoSQL, the scaling out features, and you get the best of both worlds, right? So when Spanner paper was released, there is quite a lot of hype, right? So is Spanner actually beating the CAP theorem? Am I getting CAP and all three of them, or what is it, right? Because you seem to be fairly consistent, you are partition tolerant, and you're also highly available. But strictly speaking, Cloud Spanner is still a CP system. The availability is there as a 5.9, so which is more than enough for most of the systems. So in that perspective, you can think of, oh yeah, you're getting all three of the CAP theorem, but strictly speaking, it is a CP system, right? And if you actually uncover what makes Cloud Spanner special and unique, and it is unique even now, and there is not a single equivalent database in the planet yet, is what Google calls as a true time, right? So anyone who has done a distributed programming or managed a distributed system, the biggest bottleneck is that you cannot trust your system clock, all right? I mean, there is a lot of error, there is a lot of skew, and there is no way to consistently reconcile a transaction when your system is spread across computers, spread across data centers around the world. So Google solved this with their unique solutioning, and they call it a true time. Basically, what it means is they have an atomic clock installed in each of the data centers and connected all the data centers with fiber optic, basically giving you such a high precision that you can trust the time across your distributed nodes. So that is what makes Cloud Spanner so unique. So one catch out there right now, and this is by design, is that if you're thinking it's a typical database, yes, it is a typical database, but you should be writing to Google Cloud Spanner using their own gRPC API and not SQL, but the reads are completely ANSI SQL, right? So you can think of the right path is via their API, and they have to do that to make it consistent, to be synchronously replicated across all nodes across the globe. But the reads are the standard SQL. So this is something to watch out if you're evaluating Cloud Spanner.
I think one perhaps additional point of interest with Cloud Spanner is that when Google came out with their Cloud Spanner, the NoSQL movement was at its peak. The DynamoDB paper had come, and there There had been multiple clones of DynamoDB out there. And essentially, the conventional wisdom at that time was that you cannot have transactions and scale. If you want the scale and latency, then you have to give up on transactions. That was the whole premise of the NoSQL movement. And broadly, even the academia was in agreement with that. I think it was with Google's Spanner paper that generally the march of NoSQL came to a halt when there was an acceptance that, okay, that's not the only future for us if we want performance at scale. Cool. Moving on to the next one, Cosmos DB. Cosmos DB is Microsoft's equivalent of a globally distributed database. I'm not sure, but I think they might have even come out. I think Cosmos and Spanner, Cloud Spanner might have been announced within a few weeks of each other. But anyway, so they are quite different from Spanner, but very innovative in their own way. They basically offer one thing which is very unique or interesting about Cosmos DB is they offer 5 different consistency models, and they make choosing your consistency model basically a first-class concern, which basically means that you no longer have to make a clear upfront choice of whether you want a store which is going to be strongly consistent or eventually consistent or the variation in the middle, but essentially you can tune it based on your particular transaction. And what they in fact realized is that based on usage, they found that in fact it turned out that 70% of their users did not really want strong consistency. They wanted session consistency, which basically means that I want to be very consistent with the data I have written so that when I read it, I see it. But I'm okay for a relaxed consistency with data someone else has written. So I'm okay if I don't get it immediately. So by giving this highly tunable set of consistency models, and they basically have given a lot of power to the users to basically make a choice as and when, depending on their need. A couple of other interesting things about Cosmos DB. One is they support multiple models. You can treat it as a document database, a key value store, a column family, or a graph. And the reason they're able to do all of this is because they map all of these projections onto a core model called their atom record sequence. And these projections are able to satisfy the various interfaces of additional models. Another fascinating thing about Cosmos DB is they offer SLAs on latency, throughput, consistency, and availability. They basically say they guarantee, because those are strong SLAs, that for 99.9% of their transactions, they're guaranteeing, let's say, 10 milliseconds for their read throughput and 15 milliseconds for their write throughput. And this is, regardless of scale. So that's a pretty strong belief in the engineering based on which they have given those sort of SLAs. So yeah, I guess with the Cosmos DB and Cloud Spanner, there's a very, very high standard that they have set for other vendors to match, which makes it again very compelling to use these cloud services.
Yeah, and another point just to add that the paper Spanner and the offering of Cloud Spanner, it is already inspired and influencing the open source world. I know Cockroach DB, if people have not heard, is based on Cloud Spanner, and the design has everything the Spanner has except the true time, which is very hard to replicate. But all the other designs of Spanner is in the DB. Cool. So we moved on to the last quadrant, which is the languages and framework. I'll go first. So the blip 92 is dig-dag. We have this need, right? So we talked about polycloud a bit, and then even whether you're embracing polycloud or you're within a single cloud, there is always this need that you need to have a workflow, and be it a data pipeline or any ad hoc requirement that you have, that you want to break it into tasks and run it. there has always been this need of a workflow engine, and there are plenty of choices out there. What we really liked about DigDag is that it is very lightweight and it is multi-cloud support, right? So you can have a job that transfers data from one cloud to another cloud, and it is completely language agnostic. It comes out of the box with most of the functionalities, but also gives you a good plugin ecosystem for you to implement your own operators if you need them. And the best part is that the entire workflow is can be expressed in a YAML. So even if you have a non-techie, but someone who understands YAML, who understands this operator, can write a workflow and make it scheduled and make it repeatable. And DigDag will take off all the usual tasks of a workflow, spawning things, tracking, giving you a UI. So we found DigDag to be a really thin, workflow orchestration engine, which is cloud agnostic.
Cool. I'll cover the last item that we're going to talk about in the quadrants, PyTorch. PyTorch is a deep learning framework in Python. It's a cousin to the Lua-based Torch framework, which is actively used at Facebook, actually. So PyTorch is actually gaining a lot of popularity. TensorFlow continues to remain, I guess, the gold standard for, in many ways, from a productionizing perspective. But there are many things which people don't like about TensorFlow. They find TensorFlow hard to learn and inflexible. If you want to do things slightly differently, like, for example, if you want to extract out the values of intermediate layers, they find it's doable, but it's very hard. You have to jump through quite a few hoops. If you want to conditionally execute intermediate layers, again, it's quite complicated. Also, debugging TensorFlow tends to be quite difficult. It's highly declarative and makes it quite difficult. Also, there are a lot of competing frameworks now coming up. Like, one of the original creators of TensorFlow has now joined Facebook, and he's building Cafe 2. So all this basically means that there's more people are now exploring alternative frameworks, and PyTorch is gaining traction with AI researchers. They find it a lot more explicit and easy to use. But there are still places where there are no great alternatives to TensorFlow. A couple of them being if you want it running on a mobile, for example, or if you want large-scale deployments. Or if you want some great visualizations like TensorPod, there's not an easy alternative. But despite all of it, I think PyTorch's momentum is such that we expect that to be a serious contender to TensorFlow in many ways. Cool. So I think with that, we have sort of largely covered the blips. Now, I think a couple of I don't know if you guys have seen the radar, but what we tend to do is at the end of our radar creation activity, once we have collected all the blips, we look through the blips and try to identify emerging patterns or themes just based on those blips for that particular radar. And today we'd like to just briefly introduce to you a couple of those themes. The first one is that given the list of if you look at a lot of the blips, there are quite a few which talk about Kubernetes or container managers in one form or the other. And broadly, the theme here is that 6 months ago, if you had asked, I would have said, which container manager to use? I would have said, it's still not absolutely clear. There are great contenders. There is Kubernetes, there is Rancher, there's Docker Swarm. You always have Mesos. So I would have said there are quite a few really good ones out there. But I think the momentum has dramatically shifted in the last 6 months. And I think largely based on the community, momentum, Kubernetes seems to have largely been the container manager wars. So at this point, if you're in the market for a container manager for your containers, it definitely looks like Kubernetes would be your default choice. Barney, would you like to take the next one?
Yeah. I mean, so this should not be a surprise to most. So gone are the time where you had this question of If you're starting a project, the question would be, oh, are you considering cloud for this? To know more of why are you not considering this to be in cloud, right? I mean, the number of instances where we have come across a client asking for an on-premise or their own data center based solution is gradually decreasing, right? And this coupled with the maturity that we are seeing in the cloud and the pattern, that the technique that we just described with the polycloud saying, oh, take the best of the each vendor and you don't have to be locked in for the vendor. I think this promotes the notion that, cloud is the new norm. Start embracing cloud as the first data center that you virtually own, and start building cloud native solutions out there, right?
I think this momentum is reinforced by the fact that a lot of tooling assume a cloud native approach. We talked about service meshes, for example, sidecars, all these things, right? If you are in the microservices world and you want to leverage these sort of things, then you're going to go through a lot of hoops if you want to do it in your data center. In fact, it'll become quite prohibitively expensive because it's just going to get more and more complex to maintain your own Kubernetes cluster and so on and so forth. Yeah. So, I mean, like newer tooling basically increasingly are targeting cloud native solutions, which is what makes this a new normal. Because if you at some point want to leverage all that tooling, you need to have the same sort of capabilities a cloud setup gives you.
Right. I think we are done with our content for this webinar. If you have more questions, you can reach out to us or we have like 12 minutes for the Q&A. There is one question. I think this is more on, if I remember 9 and 11, they are the micro frontends and the serverless architecture. Okay, I can quickly talk about micro frontends. So this actually, ThoughtWorks kind of coined this when we met for Radar Volume 15, 3 Radars ago. So the thought process is this. If you actually take your data layer, there is this polyglot persistence. People don't just use one DB for everything. You pick what makes sense for your problem, right? So in the data layer, we are solved. On the services layer, we have adopted microservices, so things are all quite granular. In a way, it can individually evolve. You have small teams delivering functionality. But when you go up one layer, there is this one monolithic UI, which used to call one service or many servers based on how you architect things. But you always had this one big blob of UI, which is hard to evolve and hard to mature. So the idea is, we have broken down each layer, and now could be the best time to break the front ends. And hence the word micro front ends actually was coined. Since then, the market has done quite a bit of progress on this. You would find a blip called single SPA, I think, in tools or languages and framework. That's one of the meta JavaScript framework that lets you have multiple frameworks, build small front ends, and then compose your UI as by consuming these small UI components as opposed to one big thing, right? So that's micro front end.
Cool. I think we may have largely covered the serverless architectures, but I'll just quickly summarize again. I think, as Bharani mentioned when he was talking about Apex and serverless framework, that increasingly, in the hierarchy, like people started with IaaS and then they moved to PaaS, and now you've got containers. But there is, I guess you could say, the sort of one possible end state for if you don't want to worry about infrastructure at all, and that is to entirely be devoid of infrastructure and just have functions. That's the serverless approach, where essentially you're writing functions which just assume your data is out in the cloud as well and hosted in services, and pushing outputs out into the cloud as well, and you just deploy these functions into the cloud. You don't own any infrastructure at all. So that's basically serverless architectures popularized by Lambda, but now all cloud vendors have it. I think, there's a lot of momentum in the space right now. I think we'll have to wait and see whether it starts to dominate from containers, or do containers take on more of these responsibilities?
Cool.
So the next question talks about CSS in JavaScript. I think this came out of, I guess, Facebook, which, who are the creators of React. Essentially, one of the problems with CSS is there are quite a few issues. And one of the big ones is, for example, if you have CSS variables, essentially it lives in the global namespace. Now, the implication of that is it's very hard to build components which also publish CSS, because if you're going to go into global namespace, then how do you avoid name clashes and so on and so forth? And that's when, the React movement had started, where people were getting comfortable with writing their HTML using JavaScript. And the idea which Facebook came out with is, why not do your CSS in JavaScript as well? You get all the modularization capabilities. You can use that to avoid all this global namespacing problems, so on and so forth. So since then, I think there have been a couple of iterations in this idea, and I think increasingly it's starting to, more people are starting to buy into this, where you have components which have HTML and CSS embedded in it. You just use JavaScript, and they are self-contained and don't really clash with any other component. So that's basically the CSS and JavaScript theme. So the next one is Ethereum for distributed decentralized applications. Bernie, do you have any insights on this?
Yeah. So basically, when we positioned Ethereum some time back, it was mainly for treated for their smart contract, basically, right? So not for anything else. But more and more, what we are seeing is that the Ethereum, people are using Ethereum for any site of decentralized application, right? So this is an area which is still evolving. We are still watching out, but we want to keep that in SS to say that, is it a good platform for building distributed apps beyond just leveraging smart contracts, right? So if you actually see the blurb, there is a link to the state of the distributed app. And if you see, there are quite a lot of features where Ethereum is being used in an innovative way. So we're calling out that, this is one area to keep a watch on and see how the market evolves.
Cool. Are there any more questions? If you would like information on some blips, feel free to post. If not, in a couple of minutes, if you don't get any. Okay, got one.
I can take it, and Sudarshan, you can add.
Go for it.
Yeah. So this comes from the world of Netflix, right? So basically, for Netflix, they run, I don't know, thousands, if not hundreds of thousands of services in production. And because it's a distributed system, chaos happens, right? And what they want to get very intentional about is recreating this chaos. Hey, sorry, I got muted. Is recreating this chaos and finding what happens. And hence, they introduced what people call Chaos Monkey. Basically, this, if you install a Chaos Monkey, it will randomly go, kill your service. It will crash your database. It will reboot the server in which the many things are running. And it is up to us to test, is my system resilient to this chaos? So this does not apply for everyone. So if your system is at a level where every layer has a redundancy and you want to test that redundancy, we encourage people to adopt this. This should not be seen as an envy and be applied in all contexts, right? So if your system has that complexity and has that maturity, then we recommend chaos. This thought of chaos engineering, where you expect things to fail and you want to intentionally recreate it.
Okay, I think we have the most of the questions answered out here. Sudarshan, can you share your email ID, Sudarshan and Bunny, if you have a slide which has your email IDs? Okay, so in case if you have any more questions, please make a note of the email IDs of Bharni and Sudarshan. Do write to us and we will get back to you. So from all of us from here, thank you so much for joining us. If you have any questions, like I said, please do write to us, and we'll keep hosting more of such events, technology events, and we'll keep you posted on the upcoming ones. Thank you so much and have a great day.